The question of extraterrestrial intelligence and the existential question, are we alone in the universe? The basic assumption behind the existence of extraterrestrial intelligence is inferred from the existence of human intelligence and the size of the known universe. And there has been a search for signals from extraterrestrial intelligence for several decades, with no solid results. Active search for extraterrestrial intelligence, active SETI, is the attempt to send messages to intelligent extraterrestrial life. Active SETI messages are usually sent in the form of radio signals. Physical messages like that of the Pioneer plaque may also be considered an active SETI message. Communication with extraterrestrial intelligence, CETI, is a branch of the search for extraterrestrial intelligence that focuses on composing and deciphering messages that could theoretically be understood by another technological civilization. The potential changes from extraterrestrial contact could vary greatly in magnitude and type, based on the extraterrestrial civilization's level of technological advancement, degree of benevolence or malevolence, and level of mutual comprehension between itself and humanity. Some theories suggest that an extraterrestrial civilization could be advanced enough to dispense with biology, living instead inside of advanced computers, the medium through which humanity is contacted, be it electromagnetic radiation, direct physical interaction, extraterrestrial artifact, or otherwise, may also influence the results of contact. One of the recent developments in technologies helped humans to track some of these signals from extraterrestrials. The signals that considered as extraterrestrial which received from space may or may not be an extraterrestrial generated signals, because our science and scientists have different theories explaining from where the radio signals might have originated. Few of the explanations are: fast radio burst. A fast radio burst, FRB, is a high-energy astrophysical phenomenon manifested as a transient radio pulse lasting only a few milliseconds. FRBs show a frequency-dependent dispersion consistent with propagation through an ionized plasma. As of March 2015, 11 bursts have been detected, all but one by the Parkes radio telescope. The origin of FRBs is not known. They are generally thought to be extragalactic due to the anomalously high amount of pulse dispersion observed. It has also been suggested that they may originate from nearby stars. It has also been speculated that they might be signs of extraterrestrial intelligence. FRBs are identified by the date the signal was recorded, as GM'd. For example, one on June 26, 2011 would be called FRB 110626. The oldest so far found is FRB 010621. On January 19, 2015, astronomers at Australia's National Science Agency, XIRO, reported that, for the first time, a fast radio burst had been observed live, at Parkes. Closely related to FRBs are perytons, dispersed pulses which share some of the same characteristics as FRBs, but are of terrestrial origin. Perytons were shown in April 2015 to be due to emissions from premature opening of microwave oven doors in the Parkes Observatory cafeteria, while FRBs remain as most likely high-energy astrophysical sources. In 2010 there was a new report of 16 similar pulses, clearly of terrestrial origin, detected by the Parkes radio telescope, and given the name perytons. In 2015 some perytons were shown to be generated when microwave oven doors were opened during operation, with emission generated from the magnetron. In 2013 four bursts were identified that supported the likelihood of extragalactic sources. An observation in 2012 of an FRB 121102, in the direction of Auriga in the northern hemisphere using the Arecibo radio telescope has confirmed the extragalactic origin of fast radio pulses by an effect known as plasma dispersion. Victoria Kospi of the McGill University also confirms the initial estimate of 10,000 FRBs per day over the entire sky. FRB 140514, Koth-Liv, was found to be 21%, ±7%, circularly polarized. FRBs discovered up till 2015 had dispersion measures that were close to multiples of 187.5 cm -3 pc. However, subsequent observations do not fit this pattern. In 2015, FRB 110523 was discovered in archival data from the Green Bank telescope. It was the first FRB for which linear polarization was detected, allowing, with the detection of circular polarization, a calculation of Faraday rotation. Measurement of the signal's dispersion delay suggested that this burst is of extragalactic origin, possibly up to 6 billion light-years away. Because of the isolated nature of the observed phenomenon, the nature of the source remains speculative. As of 2015, there is no generally accepted explanation. The emission region is estimated to be no larger than a few hundred kilometers. If the bursts come from cosmological distances, their sources must be very bright. One possible explanation would be a collision between very dense objects like collapsing black holes or neutron stars. Blitzers are another proposed explanation. It has been suggested that there is a connection to gamma-ray bursts. In 2007, just after the publication of the e-print with the first discovery, it has been proposed that FRBs can be related to hyperflares of magnetars. In 2015, 3 studies support the magnetar hypothesis. It has also been proposed that if FRBs originate in black hole explosions, FRBs would be the first detection of quantum gravity effects. Lorimer burst. The Lorimer burst was discovered in archived data taken in 2001 by the Parkes radio dish in Australia. Analysis of the survey data found a 30 Yansky dispersed burst that occurred in August 24, 2001, less than 5 milliseconds in duration, located 3 degrees from the Small Magellanic Cloud. The reported burst properties argue against a physical association with the Milky Way galaxy or the Small Magellanic Cloud. The burst became known as the Lorimer burst. The discoverers argue that current models for the free electron content in the universe imply that the burst is less than 1 gigaparsec distant. The fact that no further bursts were seen in 90 hours of additional observations implies that it was a singular event such as a supernova or a merger of relativistic objects. It is suggested that hundreds of similar events could occur every day and, if detected, could serve as cosmological probes. Radio pulsar surveys such as AstroPulse and SETI offer one of the few opportunities to monitor the radio sky for impulsive burst-like events with millisecond durations. The cosmic radio bursts. Since their discovery in 2007, cosmic radio bursts or blitzers have been a source of fascination to scientists around the world. The 9 blitzers that have been studied in the years since their discovery have all been plucked from historical data. Then, in January 2015, scientists announced that they identified a blitzer in real time. This means that whatever event caused the radio burst to happen was happening at the time that the scientists caught it. It is unknown what causes these radio bursts, and experts have guessed that it might occur due to collapsing neutron stars or flares. The bursts have a length of 1 millisecond and, during this minuscule amount of time, they create the same amount of energy that the Sun would create over the course of 1 million years. Emily Petroff, a researcher in Australia, stated that these blitzers occur at a distance of more than 5 billion light-years away from Earth, and the real-time blitzer was noticed near the Aquarius constellation. She went on to say that she and her team will continue looking out for blitzers so as to try and gather some information and, hopefully, one day get behind the mystery of their origin.